Okay, so this is working out the moles or concentration of a product or reaction in an equilibrium. So you can normally do moles just generally, but in an equilibrium you don't know when it's going to stop, so you have to work it out with a R.I.C.E table. So if I read the question, it says a mixture of 0.1 moles of NO, 0.05 moles of H2 and 0.1 moles of H2O is placed in a 1 litre vessel. The following equilibrium is established. Then it will give the equilibrium formula, which is NO plus H2 goes to N2 plus H2O. It has the moles here, so the 2 NO plus 2 H2O are really important, and I'll get to that a bit later, but when establishing it, the molar ratio is really important. So that's 1, because it's number 2, and the 2. That's very important. Right. Then it says, at equilibrium, or it might be Ka, but I'll get to that later. At equilibrium, the concentration of NO is 0.062 moles. Calculate the equilibrium concentration of H2, N2 and H2O. So we draw out, or you can kind of just write out a R.I.C.E table. So a R.I.C.E table, as you can see here, the R, I, C and E stands for reactants, the initial, the change and the equilibrium. And then we write out, firstly, because it's a reactance, we write out the equation. So that's the NO in here, the H2 here, the N2 here and the H2O there. So that is the reactants here, and I always like to put the equilibrium sign so I know which is my reactants, which are these two, and which are my products. Right, so this is generally in moles because it's a lot easier to distinguish. So you can see here moles, 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 it's how the question is. However, sometimes it might give it to you, one of them might be in concentration, so you just have to convert it into moles, so you all have the same here. Right, so in this one specifically, it has litres, so we're putting it in a litre vessel. So how to work out the molarity, we would go, so for example we'd work out that it was, well, we'd just write it in that what we know. So what do we know? We know that 2NO, which is here, they say in the question 2NO is 0.1 moles. So we would go 0.1 moles, because that's what we already know from the question. And then we'd do that again with the H2, so we already know that the initial, remember, is 0.05. So we put 0.05 moles of H2. And then they've also, this is a bit odd in this question, because normally for products you'd always put 0. For N2 here, because it's a product, you always put 0 because you don't start with your product. So you put 0 for your products. However, in this one you have to be careful, because just here they have put some water in it already. So you have to be very careful. So they put 0.1 moles of water, which is also a product, but for some reason they put the product already in the beginning. So we know that's 0.1 moles. But generally the products will always be 0 because you only start with your reactants. Right. So we know that right. So we know at equilibrium the concentration of NO, which is here, is 0.062 moles. So we can put that in. We can go 0.062 moles. So we know the equilibrium finish. So we can also therefore work out the change. We can work out the change between NO and the equilibrium. So we would literally just do 0.1, which is the initial, take away 0.062. So this is really important here. Before you actually write the numbers in, the reactants are always going to be negative, because you're always going to lose the amount of, so you start with 2 reactants, say, and those reactants are always going to decrease in concentration or moles to produce something else. So that also means that products will always increase. So before you do that, reactants are always negative, it's losing a number, and products are always increasing. So you would go 0.1, take away 0.062, and that is 0.38 moles. 0.38 moles. So that's the change. So we have the initial here from the initial moles that we have in the question. We've got the equilibrium of NO, which is here, and we've worked out the change by taking the equilibrium away from the initial. So that's the minus 0.38. Here comes the molar ratio. So we have 2 to 2 to 1 to 2. So we write that here. We know we have 2 to 2 to 1 to 2. So we know that if it's the same molar ratio, which it is here, NO and H2 are both going to decrease by the same amount. So H2 is going to decrease by 0.38. 0.38 moles. We know that because it's going to be the same molar ratio. We also know that because it's 2, water is going to increase by the same amount. So it's going to be 0.38, but instead of being negative, we know it's going to be plus 0.38. And here, so we see 2, 2, 2, so it's all the same. However, N2 is divided by 2 because it's 1, so you're going from 2 to 1. So you also half the changed moles. So it goes from 0.38, and then you half that, which is what is it? Oh, so that's 0.19. Right. So we know that's going to be increased by 19. So, and then we just work out what the answer is going to be. So we already know that's in the question. And then we take away 0.38 from 0.05. 0.08 from 0.35. So that's just 0.05 take away 0.38, and that equals minus 0.33. I've done that the wrong way around. And then we do the same for O. So you're going to obviously, not for O, for N2 for nitrogen. So that's obviously just 0.19. And then we do the same for the last one, which is, so we've got 0.1 plus 0.38, and that equals 0.48. So we've got our concentration of H2O, which is this one. We've got our concentration of, well actually this isn't concentration, this is, oh no, it is concentration, and this is the concentration of 19, which is N2, and we've got our concentration of hydrogen at the end point, and then you've got your answer.